Okay, today what we're going to look at is set notation and some of the commonly used symbols. Okay, so event A is a random event with a collection of favourable outcomes. So this is event A and the outcomes are B, C, dot, dot, dot. The complement of event A has outcomes that are not outcomes for A. Okay, so that would be like saying it's not raining today, okay, which means it's dry. There's no rain. Okay, so we call that the complement. If we're looking at the number of elements, so possible outcomes for event A, we say NA. We're not looking for the probability, so note the big difference there. This one here is A and B, or A intersect B. So the intersection of the set of elements that belong to both A and B. That's very important. Okay, that word and there is crucial. This one here, we call this the union, okay, or. Set of elements that belong to any of the events defined, like either one or the other. The big difference between the two is if I said to you, we're trying to decide on a 10D class song, and what we need to have is the song needs to be an intersection of both mine and your music tastes. So what we'd need to do is look through and map out your tastes and my taste and look for something that basically will suit us both. The union, if I said, hey, we're looking for something, a song that's that either I like or you like, it just has to satisfy one of those things. So it could be one that either I like, Simon and Garfunkel, Cat Stevens, something like that. One that both of us like, can't think of anything that might crop up there, or one that you like, and I have not got any examples there either because I wouldn't have a clue what you guys like in terms of music at the moment. But that's what we'd have to look for. It's going to be a very difficult job if we try to do that. The sample space or universal set is represented by this Greek letter here, and it's Z. Okay, excuse me if anyone's of Greek origin and finds that funny that I say that poorly, but that's my best effort there. That's also my best effort at drawing Z. Okay, I'm not a great drawer of Z. So that's my best effort at drawing it. And all I ask is that you attempt to draw it the same way. I think other people have difficulty with this as well because I've said here, note that there are other ways of indicating the universal set. And a lot of people revert to U for the universal set, which I don't love because that confuses or is confused with union as well. But that's just one method of doing it. Now, when we're listing the elements or outcomes of the event that belong to the set, we put it in squiggly brackets. We can have a null set. Okay, that might be the overlapping interests in music between you and I. It might sadly have nothing in it. Like if we say, listen, I'm not budging. I have to like the song and you guys have to like the song before we play anything. I'm afraid that this might happen, that we might have nothing in the set, or we represent it as the null set. This sign here is an element of, so belongs to, and I think that might be the Greek letter epsilon. All right, so let's have a look here. Complete the following: the universal set of rolling six-sided dice. So this is what can come up: 2, 3, 4, 5, 6. Number of elements in the universal set, well, there's 6 elements. Event A rolling an even number, well, what we could get is 2, 4, and 6. And we've got 3 elements. N, the number of elements in A, is 3. Event B rolling an odd number, well, we could get a 1, 3, and a 5. In which case, we would get 3 elements as well. Event C, rolling a multiple of 3. So the multiples of 3 are 3 itself and 6. Very important to note that 3 is a multiple of 3. We've got 2 elements. Rolling a number less than 4. Well, they're the numbers 1, 2, and 3. 4 is not included because 4 is not less than 4. 4 is 4. We've got 3. Interesting one. I'm going to add one here. Event E, rolling a prime. So E is an element. Okay, so let's list the prime numbers between 1 and 6. Well, 1. It's neither prime nor composite. Very important to note that. My son came home the other week or a couple of months ago from school and said his teacher said that 1 was a prime number. And I had to really grit my teeth over that one and then explain to him that it isn't. 1 is not a prime number. So the first prime number between 1 and 6 is 2. 2 is special because it's the only even prime number. 3, excuse me, and 5. So there's actually 3 prime numbers between 1 and 6. That's a lot. And the number of elements in that set is 3. Event D not rolling a number less than 4. So if I don't roll a number less than 4, what have I done? I've rolled 5 and 6. So not rolling a number less than 4. Okay, so not rolling 3, 2, or 1 means that we can roll 4, 5, or 6. So not rolling a number less than 4 is rolling either a 4, a 5, or a 6. There's 3 elements. Event A and B, or A intersect B, rolling a number which is an even number and an odd number. Well, that's looking for the intersection between these 2 sets, i.e., what have they got in common? And I'm afraid that that is an empty set. We can't put anything in there because, sadly, these 2 events don't have anything in common. It's sad. So we're going to say that this is the null set or the empty set. There is nothing in common between these 2 sets because a number is either even or odd. Can't be both. So the number of elements in A and B is 0. Event B union C, rolling a number which is odd or a multiple of 3. So it's either one or the other, but it can be in both sets as well. So let's look at B and C, and we've got 1. We've got 3 in common, so we certainly include that. We've got a 5 and a 6. Rolling a number which is odd, so that's odd, not a multiple of 5, but it's cool because it's one or the other. 3 is odd and it's a multiple of 5, so we include it. 5 is odd, not a multiple of 3, that doesn't matter. And 6, which is not odd, it's even, but it's a multiple of 3, so it's cool, we include it. So we've got 4 elements. All right, Venn diagrams and two-way tables. They were called Kano maps back in my day. Yeah, but the book tends to refer to them as two-way tables. So they're just different ways of representing the outcomes of events. So let's have a look here. So we've got a Venn diagram here, and what we do is we represent the universal set within this, okay? So we put a box around that to indicate these are all the possible things that can happen, okay? And this means that there's 3 elements that happened in what we call A only. That's that part there. Okay, that's what we call A only. So we call this A and not B. Okay, A and not B. So this one here is what we call the intersection. This is the number of elements in A and B. Okay, so they have 1 element in common. This one here is B only. Okay, so this set here, we call that B only or not A and B. And this one here, we call that neither A nor B. So not A and not B. All right, the equivalent in a two-way table looks as follows, and the things just transfer across. So notice that this one here goes there, this one here goes there, this one here, A and not B, is this one here, and finally this one is this one. What it also does is totals elements up for us, whereas this one here, you actually have to do that yourself. Not a huge amount of work, but that's the cool thing about two-way tables is it does the totals for you. All right, now a probability table must equal 1. So when you are asked to do a probability table, you've got to put a 1 down there. Okay, it's non-negotiable. Now, let's go ahead and put our probabilities in here. So this element here is there's one element out of a possible 10 elements that belongs to A and B. That's 1 on 10 as a fraction. All right, now this one here is 4 on 10. That is the same as 2/5. This one here is 3 on 10. And this one here is 2 on 10, which is a fifth. So that's totals up. So the total number of elements that are not A is 3/5. Here we've got the total number of elements that are A is 4 out of 10, which is 2 out of 5. Now, when I add 2/5 and 3/5 together, what do I get? 5/5 or 1. That's a good sign, isn't it? Right, this one here, what we're going to do is we've got 1/10 and we're adding 4/10. That's 5/10 or a half. Here, well, I know that this has got to be a half because a half plus a half has to equal 1, but let's just confirm. 3/10 plus 2/10 is 5/10. 5/10 is a half. Right, an often used question in exams or tests is a two-way table that's incomplete. And I like these, I find these fun. So what I'm going to do is complete the table, noting that the total number of elements in B is 6. Okay, so B and A, this value here must be 3 because 3 plus 3 has to equal 6. Now this element here, 3 and 1 must add to 4. 4 and something need to add to 11. That's going to be 7. 3 and something need to add to 7. That's 4. 4 and 1 is 5. And I just love how 6 and 5 equals 11. So it all just works out perfectly. All right, now we've got 2 and something equals 4. 2 and 1 equals 3. 2 and 7 equals 9. 9 and 3 equals 12. 4 and 8 equals 12. And let's just check that it works. 7 and 1 equals 8. Working nicely. Let's whack both of these two-way tables into a Venn diagram. So this one here, I think of this as an intersection or an and. So this is A and B. That's 3 right there. This one here is A and not B. A and not B is another way of saying A only. That's that part there. That's A only there. So that's got to be 4. Now B only. B and not A is 3. And not A and not B is equal to 1. Noting that if I do 4 plus 3, I get 7. 7 plus 3, I get 10. 10 plus 1, I get 11. So it's looking good. All right, let's do this one as well. So we start with the intersection again, A and B. So it might help you to put an intersection symbol there. A and B is 2. A and not B is the same as A only, which is 2. B and not A is 7. And not A and not B is 1. 8, 10, 12 equals 12 there. So pretty confident I'm right there. Yeah, again, notice the problem with a little bit with this is that if you want to get the total number of elements in A, you've got to add 2 and 2 together, whereas the two-way table actually gives you the result 4. Now, like 2 and 2 is easy. Sometimes if they're like fractions or things like that, and you've got it in the two-way table, it can be a little easier, but yeah. Those of you need to be comfortable with both of those, I tend to find some students favour two-way tables, some students favour Venn diagrams, some teachers favour one over the other. But it's about being able to use both of them because certain questions lend themselves to certain ways of or certain diagrams. All right, let's have a look at this problem here. Consider the given events A and B which involve numbers taken from the first 10 positive integers. So the universal set is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, represent the events in A and B in a Venn diagram. So let's put it together. There's A, there's B. It's a pretty bad circle, I'm not happy with that. A and B. All right, so the first thing we're going to do is we're going to look for common elements. What have they got in common? So it's a 2 and a 2, 5 and a 5. So we're going to put a 2, a 5, a 8. Yeah, okay, so we've got 2, 5, 8. All right, in A only, we got a 1, 7, and 10. In B only, we've got a 3, 6, and a 9. And I take it that's it. Yeah? Well, maybe not. 3 elements, 3 elements, 3 elements. We've got 9 elements in total, and the first 10 positive integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're missing 1. Who's missing? 1's included, 2's included, 3. Aha. 4 is, no, 4 is there. What am I talking about? 4. There it is. I'm going to leave this in the edit. So I'm happy for that mistake to go in because it's a good way for you guys to see what I'm checking or how I'm checking through to make sure I've got everything included. So at this point here, we've got nothing in neither A nor B. Everything belongs to a set. All right, so that's important to know that out here, we've got nothing, no elements. Now here's one way of representing it in a Venn diagram. We could also represent it by putting in the number of elements, so A, B, and we can have 4, 3, and 3, and 0 in that case. But this question here says list the following sets. So A intersect B equals. Now that is this part here, and because I've got not the number of elements but the actual elements, it's really easy to pick them out. So I'm going to go 2, 5, 8. Put the elements in ascending order. Okay, so there's part 1. Part 2 is A union B. And because everything fits in either A only, the intersection, or B only, it's all of the numbers. So it's going to be 1, 2, 3, 4, 5. I'm not even reading them. I just know that they all belong in either A or B. There they are. If a number from the first 10 positive integers is randomly selected, find the probability that the following events occur. Well, now this might be an easier one to use. So this is going to be A. So how many elements are there in A? Well, there's 7. So we're looking for the probability of A, which is equal to 7 out of the possible 10 positive integers that are available up here. A intersect B, so the probability of A intersect B is equal to, we've got 3 elements here out of 10. The union probability of A or B is equal to 10 out of 10 or equal to 1, i.e. it's guaranteed that you're going to get something in either A or B. Okay, so here's a really important skill that you can shade Venn diagrams. I still do this for Venn diagrams and shading questions to work out exactly what I'm talking about. So shade the appropriate region of the Venn diagram for the following events. Here's event, this event here is A. That's just this. That's the part of the Venn diagram I'm interested in, that part there. In fact, I should use some shading here. All right, B. That's just all of this stuff. A and B. So what I'm going to do is show you this via a complete set of shadings. So grab 2 colors here because this will be important to do. So the first thing I'm going to do is shade A first of all. Then I'm going to shade B. I'm going to do that in a different color. Oops. What should I use? Green, maybe. All right, now I'm going to shade B. All right, and now what I'm looking for is where it's shaded in A and B. So notice here it's only got 1 shade. Notice here it's only got 2 shades. The part that I want is this part here. It's in the middle because it's been shaded twice. So what I'm going to do is note that actually, grab my eraser, the part that we're interested in is this part here. That's A and B. All right, this one here is A or B. So the first thing I'm going to do is go and shade A. And shade B. And notice the difference here. This has been shaded twice. This has been shaded once. This has been shaded once. But it doesn't matter. It's as long as it's shaded. So this one here, I think, is it shaded? Doesn't care whether it's been shaded once or twice. Whereas this one here, is it shaded twice? That's what I'm interested in with that one. So with with and or intersection, I want it to be shaded twice. Whereas with union, I just care whether it's been shaded. If it has been shaded, that part is important to me. All right, A only. All right, so A only is this part here. Okay, also known as A and not B. This one here is B only, which is B and not A. That's this part here. All right, not A. Not A means B. But be careful here, girls, because it also means all this other gear here. All right, so not A means I'm going to have nothing in A only, nothing in the intersection, so it can't include A. And this would be like you going, hey, Mr. Miller's music taste is terrible, so the only condition on music is that it can't be in Mr. Miller's playlist on Spotify, okay? Can't be in that playlist. So what we'd be looking at here is you'd be playing a song and you're like, oh, it could be in 10D's playlist, so it could be in B only, or it could be someone else in the school. Great preppy from Juani, you know, pop on the Wiggles or something like that, okay? That could float, right? That would be fine. But as long as it's not in Mr. Miller's playlist, as long as he doesn't like it, that's cool. That means not A, all right? That'd be a bit harsh, all right? But, you know, fair enough. All right, neither A nor B. So that's what this one means. It means A or not, or A or B not. It also means the same as not A and not B. Okay, that they're both exactly the same thing. Now that one there, neither not the union, okay, is just this stuff on the outside. So again, that would be like 10D going, let's play a song that's from neither Mr. Miller's nor our playlist. Okay, so someone else, year 12 student, something like that. All right, there's probably one more that needs to go into the shading here, so I'm going to pause this video and draw up one more. Okay, so I've popped it in there, girls, albeit it's a pretty ugly looking Venn diagram compared to the ones above, but it'll serve its purpose. So we're looking for the probability of not A union not B, okay? And this is the one I highly advocate shading for this one here. This is the one I still have to shade to this day. Now, let's get the, so what I'm going to do is shade not A first of all. Okay, so not A is B only, and this outside here. Okay, and now I'm going to shade not B. Change color. The green I was using, yeah, which is not B, which is A only, and the outside. All right, so notice what's been shaded there is everything other than the intersection. Okay, so that one there actually means the same thing as this. So this is the same statement, probability of A and B not. All right, they're the same thing. Now this one here, I'll often ask this question here. I love writing questions on this because students read that and think it's exactly the same as this scenario here. And it's students who shade this one that I find get this question right. So beware on this one here, and if in doubt, shade the Venn.